Hey everyone! Welcome to this exciting course on algebraic expressions. Whether you're just starting out or need a quick refresher, this course is designed to help you master the art of simplifying and evaluating algebraic expressions. Stick around because we've also included practice exercises at the end of the video to test your skills. Don't forget to grab a pen and paper. You'll want to follow along. Ready? Let's dive into the world of algebraic expressions. So, what exactly is an algebraic expression? An algebraic expression is a mathematical phrase that consists of numbers, variables, and operations like addition, subtraction, multiplication, and division. For example, 3 times x plus 5. This expression contains a variable, x, a coefficient, 3, and a constant, 5. 2 times y squared minus 4 times y plus 7. Here we have a squared variable, y squared, another variable, y, and a constant, 7. 5 times a minus b plus 2 times c. This expression includes multiple variables, a, b, and c, with their respective coefficients. Algebraic expressions are used in equations, functions, and real-world problem solving. They help us generalize patterns and relationships in mathematics. Now that we know what an algebraic expression is, let's break down its key components in the next section. Every algebraic expression is made up of 4 important parts. 1. Variables. A variable is a letter that represents an unknown value. Common variables include x, y, and a. Example, in 3x plus 5, the letter x is the variable. 2. Constants. A constant is a fixed number that does not change. Example, in 3x plus 5, the number 5 is a constant because it stays the same. 3. Coefficients. A coefficient is the number that is multiplied by a variable. Example, in 3x, the number 3 is the coefficient because it multiplies x. 4th, terms. A term is a single part of an expression, separated by plus or minus signs. Example, in 3x plus 5, there are 2 terms, 3x and 5. By understanding these components, we can easily analyze and simplify algebraic expressions. Simplifying algebraic expressions is to combine like terms. But what are like terms? Like terms are terms that have the same variable raised to the same power. 3 multiplied by x and 5 multiplied by x are like terms. 2 multiplied by y squared and 7 multiplied by y squared are like terms. 4 multiplied by a and 3 multiplied by b are not like terms. For example, in the expression 4, x plus 3, x minus 2x, all the terms have the variable x, so we can combine them. Let's see how. We add the coefficients. 4 plus 3 is 7, and then subtract 2, which gives us 5. So the simplified form of the expression is 5x. Let's look at another example. Here we have 5 times y squared plus 2 times y minus 3 times y squared plus 4. We identify the like terms. 5 times y squared and negative 3 times y squared are like terms because they both have y squared. 2 times y is a separate term because it has only y. 4 is a constant term. Now let's simplify step by step. 5 times y squared minus 3 times y squared gives us 2 times y squared. The 2 times y stays the same because there are no other y's terms to combine with it. And finally, the 4 remains unchanged. So the final simplified expression is 2 times y squared plus 2 times y plus 4. The distributive property states that when you multiply a number by a sum or difference, you distribute the multiplication to each term inside the parentheses. The general formula is a times the sum of b and c equals a times b plus a times c. Let's see this in action. Take a look at our first example. 3 times the sum of x and 4. Using the distributive property, we multiply 3 by each term inside the parentheses. 3 times x equals 3 times x. 3 times 4 equals 12. So our final expression is 3 times x plus 12. Now let's try a slightly more complex example. 2 times the difference of 3 times y and 5 plus 4 times y. First, we distribute 2 to both terms inside the parentheses. 2 times 3 times y equals 6 times y. 2 times negative 5 equals negative 10. Now we have 6 times y minus 10 plus 4 times y. Next, we combine the like terms. 6 times y plus 4 times y equals 10 times y. So our final expression is 10 times y minus 10. And that's how we apply the distributive property. It's a simple yet powerful tool for simplifying algebraic expressions. Evaluating algebraic expressions. The first concept we need to understand is that algebraic expressions contain variables, and to evaluate them, we substitute specific values for these variables. For example, let's evaluate the expression 2 times x plus 3 when x equals 4. We substitute x with 4, so the expression becomes 2 times 4 plus 3. Now we follow the order of operations. Multiplication first, 2 times 4 equals 8. Then addition, 8 plus 3 equals 11. So when x equals 4, the expression 2 times x plus 3 evaluates to 11. Now let's try a slightly more complex expression. We need to evaluate 3 times y squared minus 2 times y plus 5 when y equals 2. First, substitute y with 2, 3 times 2 squared minus 2 times 2 plus 5. Following the order of operations, exponents first, 2 squared equals 4. Multiplication, next, 3 times 4 equals 12 and negative 2 times 2 equals negative 4. Then addition and subtraction, 12 minus 4 plus 5. 12 minus 4 equals 8. 8 plus 5 equals 13. So when y equals 2, the expression evaluates to 13. Let's explore a real-world application of algebra, finding the perimeter of a rectangle using an algebraic expression. We are given a rectangle with a length of 2 times x plus 3 and a width of x minus 1. Our goal is to find the perimeter of this rectangle when x equals 5. Step 1. Use the perimeter formula. We recall that the perimeter of a rectangle is given by the formula. Perimeter equals 2 times the sum of the length and the width. Step 2. Substitute the given expressions. Now let's replace the length and width with the given algebraic expressions. Perimeter equals 2 times the quantity 2 times x plus 3 plus the quantity x minus 1. Step 3. Simplify inside the parentheses. First, we combine like terms inside the parentheses. 2 times x plus 3 minus 1 simplifies to 3 times x plus 2. Now multiply everything by 2. Perimeter equals 2 times the quantity 3 times x plus 2. Distribute the 2. Perimeter equals 6 times x plus 4. Step 4. Evaluate when x equals 5. Now we substitute x equals 5 into the simplified expression. Perimeter equals 6 times 5 plus 4. 30 plus 4 equals 34. Final answer. So when x is 5, the perimeter of the rectangle is 34 units. And that's it. Keep practicing and you'll master these concepts in no time. Here are some problems for you to solve. Pause the video, grab a pen and paper, and try solving them on your own. Don't worry if you get stuck. We'll go through the solutions together in the next video. Once you're done, drop a comment below, letting me know how you did. Did you find them easy, challenging, or somewhere in between? I'd love to hear from you. Don't forget to like, subscribe, and hit the notification bell so you don't miss the next video where we'll solve these problems step by step. See you then.